All right, so today we're diving into the digestive system,
Okay.
specifically the small intestine.
Sounds good.
Now, we've all got one, so you
Yeah.
should probably know how it works, right?
Yeah, for sure.
For this deep dive, we looked at a ton of research papers and medical textbooks.
Definitely a complex system, but super interesting.
It really is.
Yeah.
It's like, you put food in your mouth and it comes out the other end.
Right.
But like what happens in between? That's what we're looking at today.
Exactly. That whole journey, breaking down food, absorbing nutrients, the whole thing.
So, to start, think about your digestive system like a high-tech food processing plant.
Okay, like that.
You know, raw materials come in, get processed, all the good stuff gets extracted.
Makes sense.
And the small intestine, that's where the real magic happens.
Yeah, you could say it's like the main assembly line,
The main assembly line, I like that.
where all those nutrients get absorbed.
Right, so even though it's called small, it's actually doing the heavy lifting.
It is, yeah.
So how long are we talking? Like, how much space are we working with in this small intestine?
Well, if you stretched it out, it'd be something like 7 meters long.
7 meters. Wow.
Yeah.
That's like longer than a car.
It is, but it's all coiled up in there, of course.
Right. It's got to fit.
Exactly.
But there's more to it than just length, right?
Absolutely. The surface area is where things get really interesting.
Okay, surface area, what's so special about that?
So if you could, like, unfold the entire lining of the small intestine.
Like iron it out flat,
Yeah, basically, it would cover an area about the size of a tennis court.
a tennis court.
Yeah, it's wild, right?
That's huge. So why is it so wrinkly? Like why so much surface area?
It's all about absorption.
Go.
The more surface area you have, the more space there is for nutrients to pass into the bloodstream.
So it's like more surface area, more nutrients we absorb.
Exactly.
That's pretty clever.
And the way it gets all that surface area is through these tiny little projections.
Tiny little projection.
Yeah, they're called villi, kind of like imagine a shag carpet.
Okay, I can picture that.
And then on each of those villi, there are even tinier projections called microvilli.
So it's like a shag carpet where each strand is covered in even tinier fibers.
Yeah, perfect analogy. All those little bumps and ridges create a massive amount of surface area.
Wow, so it's like nature's way of maximizing space.
Exactly. It's really efficient.
So we've got this long, wrinkly tube,
Right.
and it's divided into sections, right?
Yeah. 3 main sections.
Okay, break those down for me.
So first you have the duodenum.
Duodenum, okay.
That's where the food coming from the stomach gets mixed with enzymes from the pancreas and bile from the liver.
So that's like the initial breakdown zone.
Exactly.
Okay, what's next?
Next, you have the jejunum, which is the longest section.
Okay,
That's where most of the nutrient absorption happens.
the workhorse.
Yeah, you could say that.
And lastly,
The ileum, the final section.
what goes on there?
It absorbs some specific nutrients, like vitamin B12 and bile salts,
Okay, so each section has its own specialty.
like specialized stations along the assembly line.
I like that analogy. It really helps.
Good. Glad to hear it.
So let's zoom in on those nutrients for a minute.
Sure.
How do they actually get absorbed into the body?
Well, it's not just about the food moving through the intestine. There's a lot of chemistry happening, too.
Chemistry, like breaking things down.
Exactly.
Okay, tell me more.
So the small intestine, it's got these powerful enzymes.
Enzymes, like little Pac-Man chomping things up?
Kind of, yeah. They break down the big food molecules into smaller absorbable units.
So like carbs become sugars, proteins become amino acids,
Exactly. And fats become fatty acids and glycerol.
and those are the things our body can actually use.
Right, the building blocks.
And where do these enzymes come from?
Some are produced by the small intestine itself,
Okay.
and some come from the pancreas.
Oh, right, the pancreas. It's like a helper organ.
Yeah, it's got a lot of important jobs in digestion.
So enzymes are breaking things down. What about bile? Where does that fit in?
Ah, bile. That's another key player.
Produced by the liver, stored in the gallbladder, right?
We got it.
But what does it actually do?
It helps with fat digestion.
How so?
Well, fats, they tend to clump together.
Okay.
Bile acts like a detergent, breaking those fat clumps into smaller droplets.
So like dish soap breaking up grease.
Exactly. It's called emulsification.
Emulsification, big word.
But an important process, it makes it much easier for the enzymes to break down those fats.
So it's like teamwork, bile, and enzymes working together.
Absolutely. And all of this happens in a very specific environment.
What do you mean?
The pH level in the small intestine, it needs to be just right for these enzymes to work their best.
pH, that's like how acidic or basic something is, right?
Yeah, like the pH scale you might remember from chemistry class.
Okay, got it.
So the small intestine, it carefully regulates its pH to make sure everything's running smoothly.
Wow, so it's like a fine-tuned machine.
It really is.
Okay, so we've got these tiny broken down nutrients. They're floating around in the small intestine.
Yeah,
How do they actually cross the wall and get into our bloodstream?
that's a great question.
I mean, there's got to be some kind of system, right?
There is, and it's pretty amazing.
Okay, I'm all ears.
So there are a few different ways nutrients get absorbed.
Okay, hit me with them.
First, we have simple diffusion.
Simple diffusion. What's that?
It's like, imagine a crowded room.
Okay.
People naturally want to spread out, move from where there are lots of them to where there are fewer.
So like going from a crowded room to a less crowded one.
Exactly.
Okay, I can see that.
Some nutrients, they do the same thing.
They just drift across the intestinal wall.
Yeah, from a high concentration to a low concentration, no energy required.
So it's like rolling down a hill.
Perfect analogy.
That's simple diffusion.
Right. Then there's facilitated diffusion.
Facilitated diffusion. That sounds a bit more complex.
A bit, but not too much.
Okay, break it down.
So it's still moving down the concentration gradient from high to low,
Yeah.
but this time it's like having a special doorway.
A doorway.
Yeah, a protein in the intestinal wall acts like a doorway, helping specific nutrients pass through.
So it's like they need a key to get through.
Exactly, and that key is the protein.
Okay, so simple diffusion is like free flow. Facilitated diffusion needs a helper.
That's a good way to think about it.
What about when the body needs to absorb something, even if there's already a lot of it inside?
That's where active transport comes in.
Active transport sounds like it takes effort.
It does. It requires energy.
Okay.
Think of it like pushing something uphill.
Uphill.
Yeah, it's moving nutrients against their concentration gradient from low to high.
So it's like working against the natural flow.
Exactly. And it needs special carrier proteins to do it.
Carrier proteins, those are like little trucks hauling nutrients.
Yeah, you could say that.
So active transport, it's like the body's way of saying, we need this, even if there's already enough inside.
Exactly. It's essential for maintaining the right balance.
And finally,
Osmosis.
osmosis, that's the movement of water, right?
Yeah, it's all about balancing things out.
Balancing what?
The concentration of dissolved substances.
Okay, so like if there's more salt inside the intestine than in the bloodstream, water will move in to dilute it.
Exactly. Osmosis makes sure everything's at the right concentration.
So we've got 4 ways nutrients get absorbed.
Mm.
Simple diffusion, facilitative diffusion, active transport, and osmosis.
Nailed it.
Pretty impressive, right?
It is. The body's got some clever tricks up its sleeve.
So once these nutrients are absorbed, where do they go?
They enter the bloodstream.
And then they get delivered all over the body.
Exactly, like a delivery system.
There are 2 main routes, right?
You're thinking of the blood capillaries and the lacteals.
Right. Those were mentioned in the research,
So most nutrients, they go directly into the blood capillaries.
which are like tiny blood vessels in the villi.
Yeah, and from there, they travel through the bloodstream to wherever they're needed.
Okay, it makes sense.
But fats, they're a bit different.
How so?
They get absorbed into the lacteals.
Lacteals, what are those?
They're part of the lymphatic system.
Oh, right, the lymphatic system. That's like a separate network of vessels.
Yeah, it plays a role in immunity and fluid balance.
So fats take a detour through the lymphatic system before entering the bloodstream.
Exactly.
Interesting. So it's like 2 different delivery trucks leaving the factory.
I like that analogy.
One for most nutrients going straight to the highway, and one for fats taking the scenic route.
Yeah, it's a good way to picture it.
Now, we've talked a lot about the small intestine itself,
We have.
but we can't forget about the liver and gallbladder.
True, they're essential supporting players.
Tell me more about their roles.
Well, as we mentioned, the liver produces bile.
That fat-busting detergent,
Exactly, and it's constantly being produced.
like a bile factory,
Kind of, yeah.
and the gallbladder.
The gallbladder stores and concentrates bile.
So it's like a bile reservoir.
Yeah, and when you eat a meal, especially one with fats, the gallbladder releases bile into the small intestine.
So it's like, okay, time to break down some fats.
Exactly, it's all perfectly timed.
Wow, so much coordination going on.
It's a well-oiled machine, or maybe a well-biled machine.
I like it.
Yeah.
Okay, so after all this action in the small intestine, what happens to the stuff that's left over?
That's where the large intestine comes in.
The large intestine, the next stop on the journey.
Right, it's shorter and wider than the small intestine.
And its main job is to absorb water, right?
Yeah, and electrolytes like sodium and chloride.
So it's like squeezing out the last bit of moisture.
Exactly, and forming the waste that will eventually be eliminated.
Okay.
But there's more happening in the large intestine than you might think.
Oh,
It's also home to a vast community of bacteria.
Bacteria in our gut, that's a whole other topic.
It is, but it's worth mentioning.
Okay, so what are these bacteria doing?
They're fermenting the indigestible
The
material.
stuff our enzymes couldn't break down.
Exactly, and in the process, they actually produce some vitamins.
So these bacteria are actually helpful.
Yeah, they're part of a healthy digestive system.
Wow, it's amazing how everything works together.
It really is. All these different organs and processes all playing their part.
And we're even developing new ways to see what's happening inside, right?
Yeah, like the capsule endoscope.
That's like a tiny camera you swallow.
Exactly. It travels through your digestive system, taking pictures along the way.
So doctors can see what's going on in the small intestine without surgery.
Exactly. It's a pretty amazing tool.
It's like sending a tiny explorer on a mission.
I like that.
So to bring it all together, the small intestine, it's a pretty incredible organ.
Definitely.
It's got this massive surface area, all those enzymes, different ways of absorbing nutrients.
It's a marvel of biological engineering.
It really is, and it's all working tirelessly to keep us fueled and functioning.
Yeah, it's something we often take for granted, but it's essential for life.
Absolutely. So next time you eat, take a moment to appreciate your amazing small intestine.
I'll definitely be doing that.
And maybe think about all those little villi and microvilli working hard.
And the enzymes and the bile and the bacteria.
It's a whole ecosystem in there.
It is, and it's pretty amazing.
It makes you wonder what other systems in nature have these crazy surface area adaptations.
That's a good question.
Like, how do trees maximize surface area for photosynthesis? Or lungs for gas exchange?
It's all about efficiency, finding the best way to do the job.
Definitely something to ponder.
Yeah, food for thought, literally.
Thanks for joining us on this deep dive into the small intestine.
It's been a pleasure.
We'll catch you next time.
Sounds good.